Hello everyone, I'm Matus.
And I'm Abdurrahman Mahdi. We're mechanical engineering students at Solent University.
This is our project for TecQuipment's student competition.
Our motivation for taking part in this challenge came from the work we did in our materials engineering module, where we studied the hardness of the materials.
That experience inspired us to explore this topic further and apply what we've learned in a practical way. Our proposed research question is, what is the impact of the orientation of 3D printed materials on Brinell hardness? We know that the way a part is printed, whether it's laid flat or printed vertically, can affect its internal structure. So we wanted to explore how that might influence the material's hardness when tested using the Brinell method.
Our research plan followed three main steps. First, we carried out initial testing using materials with known properties like aluminium and brass. This helped us practice testing methods and check that our setup was working properly. Then we moved to testing our 3D printed samples. These were printed in different orientations to see how print directions affects hardness. Finally, we analyzed the results from both sets of tests and drew conclusion based on the differences we observed.
Brinell hardness measures a material's resistance to indentation, wear, and abrasion. A steel ball indenter applies force creating an indentation, which is measured to calculate the Brinell hardness number, BHN for short. We chose this method because its large indenter and high force provides an average measurement of a rough or regular surfaces, making it ideal for our 3D printed samples, where hardness varies with print orientation.
This slide introduces our compression cage, used for hardness testing. It features a 10 mm indenter which must be kept clean to ensure accuracy. The machine applies up to 20 kN of force, exceeding typical experimental needs. The specimen holder ensures precise force application, while our 20 mm non-fertile samples pose less risk than tensile tests. Safety goggles are still required in the lab.
For setup for our experiment, use a tensile testing machine. To bring the indenter closer, we use the quick advance hand wheel. To apply force, we spin the main hand wheel. The cage is where the specimen is held and then indented. The load is sensed here and sent to the digital load meter, where we get our results.
We insert the PLA sample into the testing area slot. The sample should protrude slightly from the slot to make it easier to remove later after the testing is conducted. The indenter was positioned in where it would contact the surface of the sample.
We applied 4.9 kilonewtons of force to PLA, following the recommended value for nylon 6 from a user manual. The hand wheel was turned clockwise steadily until reaching this force, taking care since PLA is softer than metals. The force was held for 15 seconds to ensure accuracy and prevent force reduction.
Initially, we tested aluminium and brass. This was primarily to practice our method with the hardness test for PLA. We managed to obtain accurate results for both brass and aluminium within 10% of the provided data.
We used polylactic acid, also known as PLA, which is the most common material used in 3D printing, using an FDM printer, short for fused deposition modeling. The settings for the 3D printing included 0.7mm layer lines, 100% fill density, taking approximately 1 hour from start to finish to print. The STL files were designed by me and Abdul in SolidWorks.
For measuring our samples, we used Vernier calipers to get the outer diameter measurements, and a magnifier loupe to get an approximation of the indent diameter.
Additionally, we used a more accurate method, known as image analysis, where we'd use a ratio converted from known measurements to find the unknown, which in this case would be the indent diameter, shown as a square in the annotated image. Printing at a 0-degree orientation results in a harder material due to better layer adhesion and a larger continuous surface resisting indentation. In contrast, a 90-degree orientation is softer, as perpendicular layers separate or deform more easily under stress. A 34% increase in hardness was observed when PLA was printed in a horizontal orientation. Therefore, orientation impacts the hardness of 3D printed materials.
Thank you for your time.
We put in our best effort and genuinely enjoyed working on this project.